So let's go ahead and get started. I don't want to wait any longer. I'm just sitting here. So hopefully the volume's okay for everybody. So first of all, before I get into the content of the discussion, which is going to be cortical columns and layers, I'm going to give you a quick update on my Twitch schedule. So sorry if you weren't expecting that, but I'll try and go quick. So I've updated this quite a bit recently. Right now, it looks like Mondays I'm going to have 2 streams. I'll have a Nementa research meeting in the morning, and then this show, AI Chat, in the afternoon at 1 o'clock Pacific Daylight Savings. I'm gonna start streaming research meetings in the Nementa office on Wednesdays and Wednesday mornings. So that should be a decent quality stream because I'll be in the office. So if you remember the video I did with Jeff, on Wednesday, actually last week, I did this in the office, so it'll be sort of that format. Hopefully I'll have an even better, where did my, I don't know why these text things keep disappearing. Hello, okay. They're just going away. I don't get it. Anyway, it works like there they are. They're right here, but they're not over here. Okay, whatever. Anyway, so I'll have a Wednesday research meeting, and then the caveat on that is we haven't had great research meetings yet. We've only really had one, and it was only about 20 minutes. It's just bad luck. You know, I told Jeff I wanted to do this, and then we just had some people out of the office, and this kind of sucks, but all next week I'm going to be out. I'm on personal time off, spring break. My kids are out of school. I've got family visiting. So there won't be any research meetings next week because I'm the one who streams them. But the week after, I'll be back and I'll be streaming research meetings. I mean, this will be part of my schedule. I'm planning on doing this throughout the rest of the year. And then Thursdays, I will be working on a community project. And this, if you're interested in HTM and how to build HTM systems, I'm going to be working on, this is on my Twitch page, so you can see my schedule here on my Twitch page, as well as, there we go, as well as all about building HTM systems. So after getting some feedback from the HTM community, I think it's a good idea to build this out. So what this is a website that I'm doing to make all these tutorials and visualizations about how to build HTM systems. So like here's an encoder, and then it shows you like that encoder running and visualizations of it, etc. I'm going to build this out. I've only made it to like encoding time, so I have some visualizations about that, but I haven't gotten through. I want to do words and multiple encodings, and then get to spatial pooling, and then I've got some big ideas here for how this is going to look. There's already some things in place, but I think this is going to be really interesting, and I want to start working on this as a part of my weekly schedule. So every Thursday, I'm going to be working on filling this document out. It's going to be an interactive document on how to build all aspects of HTM system through encoders, spatial pooling, and temporal memory, and probably anomaly detection and prediction. Okay, so that's what I wanted to say about that. So that's my schedule. So I just wanted to get that so everybody knows that's the schedule. So now let's talk about cortical columns. Before I do that, since this is probably going to go on a little while, let me fix this. I know how to fix this. Just one moment. This is such a pain. Whoa. That's not what that was weird. That's not what I meant to do at all. That was weird. This software I'm using, OBS it's called. Okay, viewers, I have to re-specify all of my text documents, and I never used to do that before they'll pop up. So just give me 1 sec, and this should be easy. Titles. What a pain. Duration. All right. Okay, so at least on my the 2 screens, I'm going to be popping back and forth, except for this one, we won't see that. Hi, Mark. I'm struggling with something stupid. There's one. Seems like every time I'm doing this. and I don't know what I need to do to fix it. Okay, there's 2. As you guys can tell, I'm still sort of new at the Twitch thing. And then my text is all whack out. So that's fine, I'll just leave it. I don't really care. Okay, so everything looks good now. That looks good, that looks good, that looks good. Okay, so before we get into this, I wanted to start with this because I liked this on HTM forum, which I'll put a link in chat here. There's one of our older members, Gary Gowlin, created this overview of the cortical column and the layers inside of it based on this video from last week on Wednesday that I recorded with Jeff. Here's the link to that video. That's still on Twitch for now, so you can watch it and see all the chat and everything if you want to. So we're sort of going to go over his diagram, or his sort of call out of the different layers. So we've got, because I like the way he built this out, and then I've also got a graphic that I took from that presentation. So I'm going to draw this back out on the whiteboard here, and then we're going to try and turn this into like a data flow diagram. So let's read through this first and talk about these layers. So we know one we're not going to mess with. We're not modeling one right now. I'm just going to take it out just to simplify it. 2, 3 is what we have here and here in the picture that Jeff drew last week. This is just one cortical column. We've sort of got it separated out in 2 places. It's because there's like these 2 sensory motor circuits that are running here. So I'll show those when I draw the picture. And why is my phone going off? I get so many spam calls lately. So many spam calls. Okay, so this is a lateral output layer, and we're also labeling it as, we think in this first loop as a place for place fields or place cells. But it's definitely a pooling layer, so it has some stable representation of a place in there. And it doesn't matter, so this should not matter where, this should be a stable representation over changes in orientation, okay? And the orientation changes are down here. So layer 4 is underneath it. Maybe we should just let's go sort of go back and forth. Hopefully we can make this work. And we'll draw a layer 2, 3. I'm going to see if we can draw this all in one column instead of the 2. Let's see if we can do that, because then we might be closer to actually creating a data flow diagram out of this. So here's, let's just put 2, 3 here, and we'll treat it just like one. I'm going to spread these out because we're going to have a lot of arrows going back and forth here. So this is 4. So things we know about this, we know this is stable. It's a pooling layer which sort of that's why it's stable. It's pooling over the representation layer 4. So layer 4, let's make a differentiation between a primary. So I think let's talk about data. Let's say if we were using and I'm just sort of floating this out here. If we're using this color arrow, let's call it a driver or a primary. Let's call it a driver signal. Ideally I'd want to separate this out between distal, proximal, but sometimes I'm not always certain that distal signals aren't driving something. So I'm just going to call this a driver, which is like a primary input signal, and then we'll have another color, and we'll call this like a modulatory signal. I think that still is a decent representation. Modulatory. Because I like to think of, if you haven't seen this, I mean, I like to think of, let me go back to the screen here. Cortical circuitry HTM school. I have a video on this, so I've got graphics here if anyone wants to watch that where I lay this out. But the way I like to think about this is let's just say any layer, just any layer. If we just treat a layer as a compute module It represents something by its cells, so it has some output. It has some output, which is its representation, and it has some driver input and a modulatory input. So it can, and I drew these like coming from the side. And typically you'd say this is proximal input would be the driver input because that's what causes cell activations. And other types of input would be modulatory input, whether it's apical or distal. But just to simplify it, let's just call it driver and modulatory. Now this output could go to another layer over here, and maybe it's this layer's driver input. Maybe it splits, and maybe it's also input to some other layer. I'm just saying theoretically. I mean, if we're talking about data flow and software diagrams, I want to break this out as generally as possible. Perhaps it splits and it's modulatory input to some other layer. I mean, all these things are possible. I mean, so these are sort of the tools and the language I think we should think about when we're talking about layers. Is the output has an opportunity to split and go in different places. The input could be, merged from potentially two different places representing two different things. What we really want to call out is this. What is this? And based on its input and output, hey, blueneuron.net, thank you for the bits. I appreciate that. Shout out to, you're a computational math, a neuroscientist student, I assume? Yeah, cool. I'll check it out. So anyway, yeah, so this is very computational neuroscience-y, because we're trying to take what we understand about the cortical layers and generalize it into a framework that we can try and build things with. So as we're going along, trying to, dissect this idea that these ideas that Jeff and I have been talking about and people have been talking about on the forums of what these layers are doing and how they're communicating, we got to think about how can we create software efficiently using these ideas, and that's sort of what I'm driving at here. Like, I want to try and treat these layers as something general, as we're trying to imagine how we can create architectures based upon these frameworks. So, ignoring this, but let's talk about these as if we know what we're talking about here. So we know that there's input, and I'm going to call this driver input. Let's change this. I always make sensory input blue, so I'm going to change these just to confuse everybody now. So let's call this modulatory. Modulatory, and this primary. Got so many markers. Okay. So we know we're going to call, where do I come from? Sensory input, or let's just say the general input to the layer is going to come from elsewhere. And again, we don't know. I think Jeff would probably draw this coming from the left. So I'll draw it coming from the left. Although, so let's not pay attention necessarily to the direction the arrows are coming, but what colors they are. Okay, so we'll draw this as a primary input from the left. And this is the primary input, I would say, to the whole system. The whole column comes in through layer 4. I think I'm sure there's some other input I know. Well, obviously there's lateral input coming in through 2-3. We'll talk about that in a minute. Okay, so let's start there, what we know there. Primary input for your skin, your eyes, all that stuff. Sensory stuff is going to come in here. And so we got to say this is where everything starts, right here in layer 4. And so the output of this connects to 2-3. So we're going to have a primary signal heading out to 2-3. And what this is going to be doing, and we haven't talked about this, this is going to be representing basically orientation over sensory input at an orientation. Okay, we haven't talked about the orientation layer yet, but we're going to get there. If you're confused about it, go check that video that I posted in chat. Right, I'm so bad at this. Right there. right there. So anyway, in through here, up through 2, 3, and I think now we're going to have to say the other there is another output from this, and here's where I'm confused, and maybe you guys can help me if anybody's knows the answer to this, because I've sort of wanted to work this out with you without running to Jeff to explain everything for me. So the signal from 4 to 5, and let's read about layer 5 now. So this said, output from layer 4 connects to 2, 3, and back to 4. Wait, connects to 2, 3. Then non-drivers connect 2, 3 back to 4, which I think is a modulatory signal. Yeah. So there is a modulatory signal here, and this is this sharing that we'll talk about in a moment, which is another type of connection. Maybe we should. So that's interesting. So we are definitely going to have a modulatory signal coming laterally out of here, and I believe you might even draw this as a modulatory signal, because I know in layer 2, 3 there are lateral connections to share this representation across cortical columns, as well as lateral connections to cells within the same layer. So you're going to get sort of a combination of sharing and a temporal pooling here. So this is like a temporal pooling, but also some of the input is all of your neighbor's input at the same time. So they're all sort of pooling together and sharing their representations. Okay, so that's sort of that loop. There's more to this that we'll get to, I think, in a minute when we talk about layer 5. But let's go down. I'm going to draw this a little further down because we have to make room for layer 5. I'll draw layer 5 here and not put anything in it yet. Okay, so then am I going down too far now? Okay, so then we're going to draw layer 6B. Or is it 6A? This is where it gets. Yeah, 6A. This is layer 5. So there is a loop here, back and forth. So let's work out what type of connections we have, primary and modulatory, from 4 to 6. So remember that this is unstable. It's not pooling, and what it represents is input. I'm going to call it sensory input. Sensory input. This might not be getting direct sensory input, but it's coming from the direction of the senses. If we're higher up in the hierarchy, we can still sort of call this feed-forward sensory input coming up the hierarchy. So this is sensory input at an orientation, and I'm going to abbreviate this ORI. So this is going to represent some sensory input at some orientation, and this will have many columns. So this is going to run spatial pooling and the temporal memory-like thing. I should probably just write this here. Many columns. Many columns. So this is SP and TM. This is a temporal pooling layer, stable. Temporal pooling. Okay, this 5 we haven't talked about yet. So 4 to 6. We're not going to talk about the thalamus quite yet, but they're that's outside of this. So 6A represents, this is going to be orientation essentially. So in entorhinal cortex, there's these head direction cells. So we believe this is the equivalent to that going on in the cortex. This is going to be an orientation layer. It's going to represent orientation. This is not going to be stable like this, because as you move, this is going to be changing. Your orientation will be changing. It won't always change, but if you change your radial orientation in respect to an object or environment that you're in, this will change. And so these are like head direction modules. We're not exactly sure how these work, but we think this is what is happening here. Head direction modules that operate similarly to like grid cell modules, but they don't select on location in a space. They select on an orientation. I think that's somewhat similar to what head direction cells work in the entorhinal cortex or hippocampus, entorhinal cortex. Okay, so we've got connections here. Major connections to 4. So there's a big connection here, and I think there's a connection down and a connection back up. So now I need to think, this is probably, we've got a primary driving connection up to here, and is this a modulatory connection or a primary connection? I'm not certain. So I'm going to read through some of Gary's notes here. 6A represents, looking right here, rotational degrees of freedom, orientation, head direction. Major connections to 4, then 4 to 6A. 6A and 4 model place into 3, right? Which I haven't put down here yet. So we could also label this place. This is sort of what this is representing. Place, sensory input at orientation, and orientation. That's what these things are representing. This is stable, running temporal pooling. This is unstable, and it's running spatial pooling using mini columns and temporal memory over time. And this is a grid cell module-like mechanism that selects on orientation as if it were head direction. I know I'm just repeating myself, but it helps me. This helps me to understand what I'm talking about. So I think something has to drive this. There's nothing else driving it. So I think this has to be a driver signal. Let's just do that. A driver signal from 4 to 6. And once we get this all out, we'll try and clean it up, turn it into more of a data flow type of diagram, perhaps. I have a couple drawings. I want to make sure I'm not getting too far away from what I thought I was going to do. So head direction. And then we've got another link back, because we need to get the orientation back to make a prediction. So this is definitely a modulatory signal back. Let's just do it like this. I don't know. And this helps us make predictions, because once we feel something, if we know where we might be looking on it or how we might be oriented towards it, we can make a prediction about what the next sensation is going to be given a movement as a part of the input here. Okay, so this is sort of one of these loops, sensory motor loops, that handles orientation, and the feed forward input drives directly into it. Does this make sense to everybody? I'm going to move on, I think, to the other loop, which is this other part over here. Okay, and this is actually, for me, the more familiar loop, because that's what the columns paper and the columns plus paper really sort of laid out. So we still have 2, 3, and now we're going to go down and loop to level layer 5. Okay, so back to 2, 3. Remember, 2, 3 is a pooling layer. It's pooling on place in this model based on orientation or sensation at orientation. It should be stable as we're attending an object, and independent of orientation. This should be independent of orientation. So this is like the attended object as we're moving through space, trying to define or model the object. And layer 5 is and this. Okay, so as Jeff sort of stated, there are 2 layers. There is an A and a B, and there's some confusion about which layer is A and which is B. And so we're just going to be real hand-wavy about that and say we don't know what layer we're connecting to exactly in here, because it's hard, because most people, because I don't think anybody really knows. But this loop is going to be basically similar to this loop. Okay, so where we have this same thing happening between 4 and 6, there's another layer down here. That's 6B. I'll attach it to it because it's pretty close to the same thing. So layer 5. Okay, let's forget about where input to layer 5 comes, but let's first show that this same thing is happening. We've got a driver here and another modulatory signal coming back. Okay, so it's the same sort of loop happening here. or a circuit going on here, where there's some type of input here, and then some type of module that's selecting on a mapping of space. And in this case, it's two-dimensional space, and in this case, it's or radial space. Okay. Okay. So we'll call this is a lateral output layer. So let's and I'm not certain. I'm really not certain if there, because when I say lateral output layer, I mean there's signals coming out of it and going elsewhere outside of the column. I am not certain about these. I don't know even if Jeff is. I'm going to write them both and let's just assume that they could perhaps be primary or modulatory signals for some. This layer could be primary or a modulatory signal for some other, for something else. I don't know. I mean, eventually, this goes through the thalamus and back up to the next layer 4. But I don't know much about this. So I'm just gonna wave my hands and say, question mark. But there's definitely lateral output here. And again, through the thalamus. So the thalamus is certainly involved over here. I'm just going to make a big general. The thalamus is involved in this loop, and I haven't talked about this yet, but there's also a cortical thalamal loop down here from 6A. So 6A, we'll get to that in a minute. Okay, so 6A. Major connections to layer 4, I've already talked about that. I'm going to 6B. Okay, this is the grid cell layer. Okay, so here's where we get some of the details. So this is not orientation, this is going to be actual location in space, not orientation to the object. And this is grid cells, grid cell modules. And this, we think, are operating in sort of the same fashion as these. Major connections to 5 in the same way that 6A has major connections to 4. 6B and 5, again, the second sensory motor loop, use place as in 2-3 for sensory motor inference. So now we have to draw another driver signal here from place. Let's try and keep it on the same. I could be cleaner about this and like move this, keep all the modulatory signals coming from one place. I might do that. So let's do that. Let's say our laterals going this way, and then there could be there is a reciprocal loop there, and then we'll just keep this clean and say we don't know about the signal. Laterally, this is, I don't think that goes through the thalamus laterally, but I'm pretty sure this, if we're talking about a driver coming out of laterally, I'm pretty sure that goes through the thalamus. Okay? Does this make sense? Am I going in the right direction, you guys? Is this clearing anything up for anybody? It's sort of making a little bit better sense for me. I kind of like keeping the data flow primary versus modulatory separated, perhaps. I don't know if it's going to be useful or not. Never tell. Okay. So where are we at? 2-3, the place circuit. Let's follow this through. Let's follow the data through. Now that we've got a diagram here, let's sort of just put all the caps on all the things here, and so we're going to start here, right here. So the input is going to hit layer 4. I'm just going to draw a little box diagram over here. Layer 4. Layer 4 goes to 2-3, and I guess we should do the colors right. It goes to 2-3, and it goes to 6A. We'll do this really simply, and then we'll try and figure out how the best way is to sort of draw it out, like tease it away from the actual neuroscience of the layer, and just try and figure out the data flow logic. Okay, that's where I'm going. That's where I'm pushing this. Okay, so I'll get my colors right here. So it's a driver to 2-3, and it's a driver to 6A. Okay, so 2-3 drives 5. I forgot. Let's just call it 5. 2-3 drives 5. Maybe I should. I don't know where this is going to end up. I'll just put it here. 2-3 drives 5. Let's just follow the driver signal. So this is 5. 5 drives 6B. Okay, driving 6B. And that's where we get. There, up to 2-3, down to 5, down to 6B. That's where we're at. 5 also drives out. We'll just point it out. Okay, there's a driver out. You guys following me? All right. Modulatory signal. Input. Let's make this green again. Okay, L4. Oh, so the first modulatory signal is actually coming from 2-3. So we're going to have a 2-3 back to 4. And then we'll have a little roundabout here because it informs itself. And then there is 6A up to 4. That's the first. This is the first sensory motor loop, the orientation one, right? And then we've got 6B back to 5. This is the second sensory motor loop. So if you can imagine, I mean, this is what we got here. We got sort of one loop here, and then one loop here. That didn't work very well. I should have done them in different colors. So one loop there, and one loop like this. Right. This is the familiar location one, and this other one is the orientation loop. All right. Dang it. Okay. You got that? Has everybody got that? I'm going to move along. I'm going to erase this one, and I'm going to try and simplify this. Does this encompass, let me ask you this first if anybody's paying attention. Does this diagram, this simplified diagram, encompass all of this information as far as the arrows and the data flow? I think it does. I think I covered everything. I might not have covered the I got the lateral out here, the in here. So basically this is in, this is out. This is the out right here, coming out of layer 5. And that's going to be like our output signal, our motor representation, however we're interacting with the reality we're representing is coming out there. Graph layout, yeah. All right, so I'm assuming that I'm sort of on the right track here. So let's wipe this out. This has more information. Take a mental picture or just whatever. And let's wipe it out and see if we can simplify this diagram even further. Okay, I got kind of a messy representation here, but I want to maybe isolate the two loops. Let's try and get this like input coming in from one direction, output going a different direction. Maybe we'll just go up, down. Or let's say input coming up, because that just seems more natural. If we're talking about a cortical column, this is actually would be the right orientation if you think about bottom up, like it's coming up through the cortical layer. I don't know, maybe maybe it's not the right way to think about it. But anyway, I know it's coming in to layer 4. That's pretty obvious. And we know layer 5 is the output, so let's try and get layer 5 as close to the top as we can. And we'll drive output coming out. Okay? And 2-3 is going to be a part of both loops, so let's put that right in the middle. 2-3. And then we've got we're going to do like 6A and 6B on either side. 6A is going to be this loop, 6B is that loop. So 6A, 6B. All right, and now let's start drawing the arrows and see if this makes any more sense at all. Got my, it doesn't matter. Okay, driver. So input comes in, right? The first thing, let's do this simultaneously. Layer 4 is going to drive 2, 3, and excuse me. Right? That's the first thing. That's the first thing that happens. But it's also going to drive 6A. So we're going to get 2 signals, right, coming out of layer 4, based off of this. So here's a question: is this happening at the same time? I don't think so. I think what's happening is we go here. We go to 2, 3 first, and we get feedback from it, right? I think that's what it is. Because this is well, this is the prediction. This will be the prediction for the next. So actually, we're going to go both places simultaneously. This is going to be happening at the same time, because we're going to, our sensory input here is going to, if we already know where we're at, this is going to have a representation in it already. So that's what's going to get updated by this. If we don't know where we're at, if we have no current orientation. I missed chat. First diagram, this post, thalamus excitation for level 4. Where does that fit? I don't know yet. The thalamus is, I don't know. I'm trying to get through, you're right, I left that part out, but there's certainly thalamic excitation to layer 4, and that's the part that Jeff talked a lot about in the last video about controlling scale, particularly being able to control the grid cell module and orientation module representations in layer 6 to basically expand or contract. So that's what Jeff thinks the thalamic signal coming into layer 4 could be used for. It's certainly related to oscillations and wave behavior. I don't think it's more than forming representations. I think it's warping representations, or it's applying a scale to the model. Like it's whatever you're attending to, it's fitting it somehow. I don't know exactly, but let me move on and try and get this straight in my head. So from layer 4, we're driving these two. This is the orientation loop. This is orientation. This is place. And we get feedback to decide, to make predictions about what we're going to feel next, which also makes predictions about where we're going to feel it next based on the movement. The movement's making, this is what I haven't drawn yet, was this. Yeah. This back to here, to help us predict the sensory input at the location based on what we have felt in that location in the past. So that's this sort of thing, I think. Okay. So we've got to 6A and 2-3, and now we have to acknowledge that at the same time that this is occurring, this driver input gets to 2-3, and it is immediately driving layer 5. As this loop is resolving, this loop is also resolving. You have to think about this happening at the same time. So again, we've got layer 5 in the same way that layer 4 is primary input for layer 6 and gets modulatory input back from layer 6A. Layer 5 and layer 6B sort of have the same relationship. Now, I think this is a pretty clean way, I think, of looking at this, and I think it represents basically the cortical column structure, just in a more data flowy way. I mean, you could even, if we could even clean this up a little bit and just put, 6B right here and 6A right here, and just clean this up and say forward, back, modulatory, and then get rid of this one, just so we've got a cleaner sort of diagram and everything's nice and isolated. So, but now we have to think about the thalamus. So, yeah, I was thinking about adding a time ticker to this. That would, one of the things we do in the columns plus paper is we'll put like a, let's take a look at that actually, because that is a good, it has some diagrams that would be really useful to take a look at. I'm pretty sure I download this paper every time I need to look at it. So, let's see, latest stuff. 19? Yeah. Here it is, locations. Oh, there we go. So you just saw one of the graphics here. Here's the paper in Frontiers, but oh man, where do I download it? Thought it just downloaded. Articles about. There used to be a link to download here. That's weird. I have this somewhere. Let me just search my hard drive. I've probably got 6 copies of it. Honestly. Okay, hold on a moment. But there's some good diagrams in here. Here it is. No, that's not it. Where is it? It's, using grid cells for coordinate transformations. There it is, columns plus. Okay, this may be an older version, but I imagine that the diagrams are probably the same. Okay, here we go. So this location would be the location layer and the sensory layer. So the sensory layer, we would call that layer 4, and the location layer would be 6A in this case, or 5 and 6B. It's the similar loop, right? So it's basically motor input to layer 4 is 1, 2 is driver input to the sensory layer. Oh, motor input to the location layer. So I don't even have motor input to the location layer. Maybe this is maybe this doesn't work. Maybe this is outdated. Because we have a movement signal coming in here, and that would be coming into, it would have to be coming into either 6B or 6A. So I bet that, so if the input 6E or 6A is the one coming from the thalamus loop, right? Major connections, 6A, model in place, provide sensory motor inference. Output to thalamus, but there's also input, I think, here. Where is modal information coming into the diagram? What do you mean modal information exactly? Model information? Or I'm a little confused. So this has reference to movement as an input, and I for the life of me can't relate this to what I'm drawing here. Back to, where's that picture? Here it is. Where'd it go? There we go. So I know that there is a loop here from the thalamus to, well, that's weird. There we go. Thalamus to 6A, that's sort of halfway drawn here. So I think that the movement information must be driver input to something. I don't know. I'm gonna have to ask that question, because I don't think I understand that. So I'm just trying to relate the idea of these time steps here in the columns plus paper, starting with a movement coming into what would only be either orientation or location layers, which hold grid cell-like modules, or orientation or head direction-like modules, which would then, I think, modulate the sensory layer, which has already gotten sensory input, right? I think ideally we're going to get sensory and movement information at the same time. So I don't know how to draw. I don't know, honestly. I don't know exactly how to draw the numbers here, but that's something I will look into. So this is certainly going to be 1, and the question is, if we've got motion information being fed somewhere into layer 6, where is it going, and is that simultaneous with 1, or is it going to be 2? I don't know. So I'm gonna dig that out and figure that out. But I know, so based on so this is outside of columns plus. This is the columns paper. So I'm not certain if this is 2, these are both 2 at the same time, or if this is 2 and then this is 2. That's a good question. That's something to figure out. So I'm gonna investigate that. I'm gonna ask Jeff about that when I'm in the office on Wednesday, and see if we can take this diagram and add these time ticks to it. That would add some information for us as we're talking about how to do this stuff in software. So I think we got a decent amount through here, kind of converting the cortical column to a data flow diagram. Oh, we were going to talk about the thalamus too. So let's see if we can think a little bit, at least through what Jeff was talking about last week with the thalamus. So he drew the thalamic loop down here, and he said there's a ton of data coming from layer 6A to the thalamus. And then there's a loop back. The thalamus then loops back in to be a part of the input. I think this is in the same layer. This is not going off to another level of the hierarchy or anything. So we should probably try and represent this. But again, I'm not sure at what step in this loop this is really happening, or if it's just sort of simultaneously happening, So think about this. We know there is, and I don't know if this is modulatory input, driver input, or what, but we know at least Jeff has drawn here that there is. Let's draw the thalamus in red, because why not? I had it in red earlier. And we'll just say this is the corresponding layer of cortical cells that operate with this cortical column in the thalamus. So if we've got something from 6A going to the thalamus, and then whatever this is doing is contributing back here. Okay, so that's what I know. I don't know much more about that. I mean, okay, let's do this a little bit better, because one thing we do know is that all of this is coming through the thalamus. Let's draw it as a circle. Everything's coming through. All this input is synapsing in the thalamus, coming from wherever it's coming from. All of this input is synapsing here on relay cells and pushing through to the cortex. And so now let's draw this in the right place. 6A feeds back a lot of information to the thalamus in order for it to decide how to modulate this signal, I think, is the point of that. I wouldn't be surprised, I'll ask Jeff about this, if 6B doesn't do the exact same thing. So we'll see. Okay, so I'm going to write down some questions for Jeff. For those of you who don't know, Jeff Hawkins is my boss. He founded the company Nementa. Questions. So one is timing. Timing, especially between the two loops, the two SMI loops. It'd be great if we could add those time ticks to all these, and then because then we could sort of animate it out and play it out, like what's happening at the same time. Tachyon says, is the thalamus decoding the inputs from layer 6 as it was represented in L23? When it reroutes, when it does this rerouting, is it decoding the inputs from the L6? I'm assuming you're saying layer 6 as it was represented in layer 2-3. What you've got here, I mean, if we're talking about layer 6 in our model, layer 6 is going to be either location or orientation information. So it's like in the context, within, while attending a thing, an object, it would be somehow the current location and orientation information, not necessarily the sensory. Well, it would have some sensory information, you know, coming because it's getting feedback over time. It will build up some sensory information, but if this is the representation out, this is going to be a location, and this is going to be an orientation. So perhaps it really is only location and orientation. Is that all this is? So the thalamus is getting, there's another question. Thalamus input from L6. I'll just point to that. Location and orientation. That's what it has to be. That's the only thing that we really have here is a location and orientation. So it's like a new input space on itself when it gets rerouted. I think maybe it's just, perhaps it just needs to know the current aspect or point of view to the object under inspection before it can apply a scale. I mean, it sort of needs to know, where am I at now before I have to know the current situation before I can imagine it bigger or smaller or scale my expectations. I got to know what I've got right now. I'm assuming, because assume that, let's say you're running, right? You're running. As things pass you and you attend to them, they're going to change scale constantly. So this could be like the current state of its current location orientation relative to you. So the thalamus knows as you flow by it to predict what the next state will be, or to inject back in there how big that thing should be as it passes you the whole time. Does that make sense? I think could be what the thalamus is doing. At least that's the way Jeff explains it. So I think I'm explaining it the right way that he would explain it, but we'll see. So what were the other questions? I got one on timing. So we're going to try and resolve the timing. The thalamus loop, like what is it? What's it injecting? And then there was one other thing, right? I think there was one other thing that I wanted to ask him. Maybe not. Let me look at the screen here. Yeah, that could be it. Okay. So this is where we got after an hour or so talking more about cortical columns is some direction, I think, towards simplifying, this diagram over here to something perhaps a little simpler that we can relate more towards software architecture. Will says another thing that might be useful to visualize is the amount of information that flows between the layers. Yeah, that's true. Like, for example, I know this is super thick. This is super thick. Yeah. And I'm sure that people know this. And if you guys are interested in this, there's a guy on the forum named Casey. I'm going to find it. Turn that off. Okay. And he did this whole thing. Cortical layers, author, Casey. I think this works. No? Cortical layers. There it is. Layer 2, 3 notes summary. So this guy has done some really nice notes. So he did one that was like the whole cortical column. I swear, I thought there was one. Let's just do where is it? Posted by Casey Walshwalder. So here's he took a ton of notes on layer 6, and I perused through this, but I didn't. I'm sure we could find a lot of this information. If anybody wants to do a little research and help me answer these questions, the timing, the size of the inputs, perhaps, you really might be able to find everything you need in an HTM forum, because there's a ton of neuroscience stuff posted on this forum, especially in HTM theory neuroscience. I'll post it over here. There's a lot of resources in there, if you can sort them out. And this stuff from Casey is particularly, I think, high quality. It's got a lot of references and stuff. So here's what happens in layers 5 and 6A. Lots of conversation about this. I mean, we don't have time to weigh in. I certainly don't have enough knowledge to weigh in on a lot of these neuroscience conversations. But there's quite a few people on the forum, including Mark Brown and Casey, and there's a few others that seem to be primarily into the neuroscience that really have some informed posts here. So definitely take a look at the neuroscience section of HTM forum. Okay. So that's another thing. I'll put thickness. It's not really thickness, is it? Amount, information, density, something like that. Okay, information density. We'll call it that. Okay. All right. So I think we're going to wrap up this chat, this little session, and I will, when I go back to the office, I'll probably show some of this to Jeff or Subutai and ask them these questions, and to see if they have anything that can help inform us. And I'll post about it on HTM forum. Sound good? Appreciate you guys taking time to watch the show this week. Next week on AI Neuroscience Chat, we're going to talk about an AI license called the Responsible AI License. It's something that I've seen floating around since we have an open source artificial intelligence code base. I thought it would be a good idea to review that license, and we're just going to talk about it. I'm going to talk about it live and what I think about the license. I haven't even looked at it at all, barely. I mean, I sort of get the gist of it, but I'm going to talk about whether we think we should maybe adopt that license, and we'll see how it goes. So we'll talk sort of about responsible AI a little bit in the next chat. If you want to come, so it won't be that technical. If you want to come talk about the philosophy of AI or what have you, the effect it could have on humanity and safety issues, that would be a good time. It'll be again 1 o'clock Pacific Daylight Savings Time. That's UTC -7, Monday, 1 week from today. Thank you everybody for joining. Let's go raid somebody. It's Twitch, so let's raid somebody. Sometimes I forget to do this. So let's see, who do I know that's currently online? We could always go back to Raimu. I don't know this guy, Dino D and Nugget. I don't know this guy either. Let's go back to Raimu doing his C++ stuff. Let's raid him. He's a good guy. Raimu, what's his name? 8354. Thanks for sticking around. Those of you guys who are sticking around for the raid. Whoops. I gotta say his name right, first of all. Okay. Close. I think I did it. Yeah, all right, so we're going to be ready to raid. Let's go raid them. Thanks, everybody.